Alrighty, going to wrap up this IR Blaster project. Took a couple days off and did some other things and did some troubleshooting and left all that crap out because, yeah, I think it took me a lot of back and forth trying to figure stuff out, and I don't know that everybody wants to watch that, so I'll sum it up for you. Just to kind of recap where we left off, I was having some issues with logging out milliseconds and logging, or actually reading and writing from the EEPROM. It wasn't behaving. I'm actually not sure that I can talk over this music. Or miss you, Jackal, but alright. Where was I? Yeah, so I was having some problems logging milliseconds and reading from the EEPROM. I was used to the way that the ESP8266 did it, which is not the way that the Arduino does it. And so I had just fixed a couple things. Everything, the structure of the program is more or less the same. So let's recap. That's the recap. I added a couple of things. I did a little long to string function here. I used it a couple of times. I figured I would write a function. This didn't change. This still does the same send. And here's where the EEPROM stuff came in. For the Arduino, and basically you have to write to each address in the EEPROM. And I was trying to store along, and it doesn't look like the ability to write along natively to EEPROM is there. So I would have had to figure out how to take that long and write it to the EEPROM. It's probably super simple, and I would be a smarter person for learning that, but instead I just used a library called EEPROM EX, which is just an extension of the EEPROM library that allows you to do, it just, it encapsulates some of the stuff that I need to do. And that you can go check that out in the library. I just went to PIO Home Libraries, and actually it's still on that because I was just there. I just did a search for EEPROM. Let me show you that, actually. I do it this way. Yeah, it was like the second thing down here. So this was like I think this was like a testing library, and then this was like, hey, make, store strings and longs. And then all the documentation is right in there. And that's exactly what I was trying to do. So there you go. All right, let's go back. There's just a couple of pieces of syntax to get the EEPROM set up. I wanted to declare the size of the EEPROM memory, and for the Arduino Nano, or this, I guess this is Uno. That might be wrong. It's supposed to be Nano. Interesting. Yeah, Nano. That's better. The Nano has like 256 KB or something, like a tiny little amount. And so, but anyway, plenty for a single long variable. And then there's just this is like some protection to make sure that we don't accidentally write the EEPROM to death, because there's a limited number of writes the EEPROM can handle. It's like 100,000 or something. I'm probably wrong. Anyway, so now the library made this quite easy to just read the long from starting the 0 address space, and I stored that into my startup delay, which is a long in and of itself. And then I just log that out to serial. I fixed that millisecond logging problem. Yeah, I did it like this. I could probably inline this L2A function here, but whatever. So I make this milliseconds into a string, and then I concatenate the payload to it, and that seems to work really well. Funny part is the way I intend to implement this initially does not allow for bidirectional, so the logging is sort of like maybe I'll use it later, I guess. I haven't started implementing the logging for the tables yet anyway, so at least it's there, and now I can access it. This is just, I can probably comment, remove this. This was just when I was testing my EEPROM code. And then I just did, what else? A little bit of stuff with serial. I checked, this mostly stayed the same. I just said if we have serial incoming and it's a D, then go ahead and loop while we're getting data, and while it's not a carriage return, and while we haven't exceeded the maximum number of digits, so 99999, just to keep it safe within the long range. And like again, I don't know if you need a 10-second delay between your cabinet starting up and the television coming online. So I don't know, whatever. All right. And then this all stays the same. I'm just basically concatenating a string together of the digits received from serial. I print that out for posterity, cast it to a long from the character array from the string, and then because the D mode is for setting the delay, once I receive that and I've cast it to a long, I store it in EEPROM, again leveraging that EEPROM X library where I can just do a write long to the zero address space and startup delay. Now, if I wanted to store another variable, like after that, I presume you would do something like EEPROM write long size of maybe long, I guess. And so +1 something. I don't know. I'd have to goof with that. But basically, you'd start after the length of a long variable. And I presume it would be just the size of the type, not the size of startup delay. Anyway, we're not going to do that because we only need to store one thing. And then so that's just the case of setting the delay, and then otherwise it would just be the incoming character being P, which would send that power command, which is the thing I had up at the top, send NEC. This is where you would fork the code off and create your own. You'd look at the IR send library, and due to the beauty of Visual Studio Code and integration with PIO, I get my type ahead and autocomplete, which is great. And so you can see all the different send types here that you can send out. There's probably guidance online for how to do that too, but this is a simple one for the TCL, whatever, I don't know what size it is, 43-inch TV that I'm using. Okay, so that's that. And then you would do a build and you would upload it to your thingy, right? Let me go plug in my Nano so that we can watch this work. And hopefully I can point it away from my TV and it doesn't shut that off. Alright, so I've plugged that guy in there. Probably could have heard that noise. And let's upload it. I don't need to do this because I've already got the code on there, but at least you get to see the process. Now, and it should flip automatically over into monitor mode, but it does not. Okay, let's go back to it. There we go. So now you can see at the 0 millisecond mark, right when the code starts, we get a little output. We know that it started. We've read from the EEPROM, we've got this currently set to 1 second. And then at the 1 second, 1000 millisecond mark, it says the delay has ended, sending IR code for power. And then the little LED blinks and the TV turns on and off. Now, if I were to take, so great, that's exactly how I want it to work. And if I do type in capital P, there we go. At 30 seconds of runtime, it sent the power signal, and you can just do that over and over and over again. And then if I wanted to program it for, let's say, 10 seconds, 10,000, I can just copy and paste that into the output here. There we go. You see the output, the debug, added digits, received the following string, 10,000, set it up, wrote it to EEPROM, and then if we were to send a reboot command to the guy, now you can see it's going to delay for 10 seconds and then send the command. So that's cool. Now for implementation, cool, there you go, perfect. For implementation, I'm going to just use some PowerShell. And if I do want to implement logging and I want to actually capture the output from this, which I may, I'll probably just write a quick little C# script or something. I don't want to screw around with trying to do like bidirectional asynchronous stuff in PowerShell. I don't know it very well, but I know that I could do it in about 15 minutes in C#, so that's probably what I'll do. As for PowerShell though, I'm going to just, for the quick and dirty, I'm going to embed this into a batch file, and what this does is really straightforward. I'm a big PowerShell fan and pipeline fan, so what we do here is we open up that serial port. This is hard-coded to 14, that's what happens to be on my system. Yours would be whatever it is in Device Manager. that creates the object, and then I pass that through the pipe and then enumerate. There might be a better way to do this, but this works for me. And so I enumerate through each object, there being only one object, but this allows me to enumerate and get this is the object access variable for whichever iteration we're in. And so I'm calling essentially serial port com14 open. That opens up the port. Then I do a write line of that capital P character, which invokes the power on, power off, and then I close that port so that we don't keep a lock on it. And so if I were to do that, I can just do that. And unfortunately, I don't have a camera set up yet and to make this work with my videos. But what this does is sends that power command to the device, and it signals out and runs its code. And actually, I'm sorry, I'm getting distracted here because I actually don't think it is, and that's wigging me out. It should work. So let's see. In the long way of doing this, you can see the code up above here. This is the line by line method of it. So let's go see what's happening here. Can we do a port.open com14? Okay. Yeah. And now if I were to do, God, sorry, no, don't port dot write line. We say P. Oh yeah, that's working. That's really strange. Why would that work? Port.close. Okay, cool. So let me run this script again, just the inline script, because this is actually what I have in my batch file. Oh yeah, okay. So there was something, maybe there was something locked. I had a port already open or something from a previous session, but that is working now. Great. Now what I've done with that is, let me blank the screen right quick because I want to go find that file that I created. I don't, you never know what you're going to get into. All right, documents maybe? What the hell? Where did I put that thing? Well, the long story short is all I did was I created a batch file that has, that calls the PowerShell command. Maybe I have it over here. Yeah, there we go. Here comes the screen in just a second. Okay, so I just had, it was in my, just the rootedy, I guess. So if I type power off tv.batch file, all that does is call PowerShell, and you can inline PowerShell commands directly from batch file, and you'll see. And this is stupid that you have to do this, but because maybe you don't. Maybe there is a way to just I can invoke PowerShell directly from this registry key that I'm about to put, or this group policy object, but I should be able to probably put PowerShell directly there. I don't think you can. Within there, I'm just inlining this command that I illustrated over here. And then the one caveat is that because it's a batch file, you have to essentially escape your percent signs, because that's the variable indicator or the syntax in batch file. But otherwise, it's exactly verbatim. Now, if I were to execute poweroff.tv.bat, it invokes PowerShell, which opens up that port, does that thing, and I just verified that it does work. Now, the reason I put it in a batch file is because if you open up your group policy editor, this would be, your local group policy editor on your pinball cab, and navigate to, and I think that would just be gpedit. Yeah, gpedit is the way to do that. You can also use the MMC. But if you navigate local computer, computer policy, Windows settings, scripts, startup, shutdown, you should be able to make this visible. Shutdown contains shutdown scripts. So you double click that, you add power off TV, whatever. Actually, no, That's not how it goes. You navigate to it. Go find what you just created. Power off TV.bat. Don't need any parameters. Click OK. Click apply. Okay, whatever. Now, when your computer shuts down, so in my cabinet, I have a button that I press that initiates a Windows shutdown from the motherboard, through the motherboard. And so what that presumably will do is invoke this shutdown batch file, which will then power off the TV. And the way that I have my cabinet wired is that the television is plugged into an always-on port. The reason being that what I was experiencing when the television was plugged into a port that got turned off when the cabinet got turned off is that the TV would take a long time to turn back and like basically initialize, I guess. Whereas if it's plugged in all the time and then you let it go to standby, the power command is really instantaneous. Basically, like the TV turns on within a second or two. Whereas like from the raw, like from the no power state, it was like maybe 10 seconds or something. Again, I'm just doing this because I want the TV to be powered on and have the ability to have that HDMI signal sent to it from the PC pre-boot or like really early in the boot process to ensure that it's designated as monitor number one in on the software. I don't know that it's really an issue because it's physically where the monitors are plugged in. I think makes more of a that's more important. But anyway, this is the way I want it to work. So when you hit the power button and it starts turning off the PC, the TV stays on, but it will get the power off signal. Meanwhile, all the fans and the Pinscape board and all the peripherals and all the other stuff that's powered by 12 volt and 5 volt will get shut down to save on any sort of power drain. So the only thing that's actually drawing power would be the TV standby mode, which is a pretty small amount of power, as well as the power supply and its standby mode, I guess, for the PC. And that should be the only draw on the whole system. Even the backglass monitors are actually plugged into the switched ports, so that the backglass monitors come on as the rest of the cabinet turns on. That wasn't as much of an issue because, first of all, they're not my primary monitors, and secondarily, they are PC monitors and not televisions. So they turn out like one of them is a repurposed laptop monitor, and the other one is just a standard PC monitor. And so they come on super quick. There's really no initialization process, so they actually boot up just as fast as I would like them to. And they come up automatically, right? They turn on by themselves, whereas the TCL monitor or TV screen or whatever doesn't. It does once it comes in from a power off state. Like if you yank the plug and put it back in, the TV doesn't come on from even if that was its last state. Even if it was on when the power was pulled, its default state is off. So having the power on is really clutch. Okay, that was a lot of explanation. Sorry about that. Anyway, so that's how you implement this script into the shutdown. I am currently 3D printing. Let's see if I can find it. Let's go to it. Let me do this off screen. 1 second. Just double check. Yeah. Okay, so let's see. I've got looks like an hour left. This is probably a little bit. It's probably more like an hour. Anyway, I added some ways to affix this thing to the side of the cabinet, and SketchUp is good. Hello, lady, whoever you are. If I look at my SketchUp library, I have modified the case this morning to reflect a couple of design changes. First of all, this would be the north vertical facing because this is where the infrared light comes out, shoots out this way. I just added these little tabs here so that I could screw it into the cabinet and secure it that way. Yeah. And then I also, this used to be at an angle, and because I'm actually using the soldered on pins and I'm using DuPont connectors, I'm not soldering these directly onto the Nano, so I need the clearance for the standoffs here and the wires to come down. But in any case, it also makes this a little bit easier to craft the case cover because it's more of right angles, and I don't have to account for there was something I didn't want to do. Yeah, there were like the way that anyway, it doesn't matter. This is easier. So I'm gonna print out this little case cover with maybe with some decorative design on it, and then put it inside the cabinet. Okay, well, let this finish printing. In my next video, uh, I'll probably show the cabinet inside, I guess. If there's anything anybody wants to see, you can post a comment. I do have more than 0 views, which is super awesome. Appreciate anybody that cares to listen to me. So I'll get this installed, and then I'll show the cabinet, and then I'll try and illustrate. I think I'm going to order. Um, Hang on, I'm going to do this dark screen thing. I'll probably find a better way to do that too. Um, Maybe it's, I don't know. I have to learn OBS or look for something else to do like video transitions easily, so that while I'm composing this stuff, it's more natural. Anyway, what was that called? There's a really cool cam. I was at the CC AG show, and this lady came by, and she had um, a DJI Osmo, I think it was called. Yeah, let's check that out. Right, it's one of these, not this one. It's the consumer Osmo Pocket. This thing is freaking rad. 4K with nice stills too. 3-axis gimbal. Um, yeah, it's freaking cool. So I think I'm gonna buy this, and that's what I'm gonna use to do my anything that's not me narrating into the video. Sorry, I'm getting a little bit long-winded here. These are pretty pricey though. This is like 350 bucks, so we'll see. I'll probably wear it soon though, because I have no self-control. So I think that's it today. This is all working. I think it's gonna work good. Um, there's probably I could probably go to GitHub and like find or whatever, just Google and find the same thing already done. But at least I learned a lot. I know, I took away now. I know how to interact at least. Even if it's an extension, I know how to interact with the EEPROM on the Arduino a little bit better. That's something I hadn't done before. And couple together some widgets. It's pretty straight. I mean, this is easy stuff. This is like Lego parts that you stick together, and it just sort of works. I don't have to wire in any of my own resistance, or I don't have to calculate it. It's just 5 volt, and you plug it in, it works. But anyway, yeah, quick, cool little project. If you have any comments, leave them, and I will come back with another video. Thanks, bye.